Hi class, let's take a look at example 4. In an example 4, take a second and read it, but we're looking at a claim on the standard deviation being less than. And remember that any claim that is less than, it's going to have this as the main region. Here's the main formula for the test statistic. And then for the actual critical value, we're looking at a left tail test. So please check that on this particular one, after you run the one variable stats, that you're matching to the standard deviation. And I'm just going to carry 4 decimal places. So for this problem, we're going to be using the values of n is equal to, and I'm counting 1, 2, 3, 4, 5, 6. N is equal to 6, so degrees of freedom is equal to n minus 1. So degrees of freedom is equal to the values of 5. We're going to be using that the sample standard deviation, it's going to be 0.50. So 0.50, 1, and 3. I'm going to carry 4 values on the standard deviation just so that we match with the code 0.0. 1, 5, 0, 1, 3. Okay. And then, well, the claim is that in terms of pounds, the standard deviation is less than. So I'm just rewriting it again. And for this one, I'm just going to say where sigma is the population standard deviation. That's just to make it clear that we're talking about a claim on sigma. And then our hypotheses are actually going to look as follows. Since it's a claim of less than, we could rewrite our HO being the values of sigma is equal to 0.47 pounds. And then your H1 or HA, sigma is less than 0.47 pounds. The other part that I wanted to mention before we go into calculations is that they want us to use the p-value approach. So on the p-value approach, we have to state the claim. We have to state HO and HA. And then from here, we jump directly to the test statistic. Now, for this particular problem, I want to do the critical value, but it's technically just so that we have it and we look at a little bit more practice. So let me do the critical value here. Now, once again, the critical value is not needed for the p-value approach. And in this case, we're looking at degrees of freedom to be the values of 5. Our value of alpha is equal to the values of 0.10. So therefore, C is equal to 0.90. So if we look at the critical region, we're going to be looking at a specific, critical value that's going to be in this area. And this area here, it's going to be 0.10. And this area here is equal to 0.90. So we're looking for a critical value that has 5 degrees of freedom and then 0.90 to the right. I actually have it here. So we're looking at our critical value of 1.661. So our critical value, it's going to be approximately approximately 1.610. And let me double check. We're looking at 1.61. We don't need the extra 0. So once again, here we have it. This is a critical value with 5 degrees of freedom and 0.90 to the right. Okay, and we technically don't need it, so I'm just gonna box it out. Technically, when we're doing the p-value, we can jump directly to the test statistic. And that's going to be step number 3. So on our test statistic, this is going to be equivalent to, well, the values of 5, the sample standard deviation, it's 0.5013, and don't forget that that's a square, and then the actual claim contains the 0.47. So this will be 0.47 squared. Please evaluate that on the calculator. And I'm getting 5.688. I'm just going to carry an extra value there, but 2 would be sufficient. Okay. As we calculate the p-value, well, we need the actual test statistic. Also, this is a left tail test. So your p-value is going to be this area, but for the sample. So that means that we're going to have, and obviously this is not to scale, but I'm just going to put it here. This is a chi-square value of 5.6881. And this area here, because we're dealing with a left tail test, will be the p-value. So p-value is equal to area to the left of the chi-square value of 5.6881. Okay, I already have it here calculated, but let me show you how to punch it in into the calculator. So in this case, activate the distributions, and you're going to be looking at a chi-square CDF. Now, our value happens to be to the left of it, and the chi-square distribution starts at 0. So this one will say 0, comma, and then 5.6881, and then the calculator requires, or this particular one, the degrees of freedom. So in this case, we're simply gonna punch in 5. Let me hit enter, and our p-value is 0.6622, which you technically see the code here. And let me just write it out as the p-value. So in this case, the p-value, it's approximately 0.6622. I'm just going to carry it to a total of 4 decimal places. So let me just back up a little bit for this particular one. We don't need technically the critical value because they're requesting the p-value approach. So technically, from stating the hypotheses, you can jump to the test statistic and then directly go to the p-value. Now, our conclusion is going to be based on the following. So the value that we came up with, the p-value, it was 0.6622. Then you have to compare this value to alpha. Alpha was 0.10, which is from here. So alpha is equal to 0.10. And let me box this in. Now, once you have both of these values, you're going to do the following comparison. And the comparison is technically here. You're going to be looking at, and what this is doing is technically looking at the picture of the population versus the picture of the sample and determining if they're approximately the same. So you're basically looking at the following. You're looking for the statement that fits. In this case, we're looking at this sort of a statement. Our p-value is greater than alpha, so we are going to conclude failed to reject HO. So let me write it out as failed to reject HO. And you could just say because the p-value was, and let me write it again, p-value was approximately 0.6622. We ended up having a value that is greater than alpha, so happens to be greater than 0.10, which is equal to alpha. And in terms of a conclusion, this is sufficient. So it's the same idea as the test statistic fell to the right of it. Remember that when you're looking at the rejection region, you're technically looking at where in space is this value happen to be on. This is under your fail to reject region, not the shaded one. Except that in that case, we would have said fail to reject because the test statistic of 5.6, it's greater than 1.6. Another way is technically the p-value, where you're basically comparing the p-value to alpha and then using this idea here. If it's greater than alpha, fail to reject. If it's less than or equal, reject HO. And for this one, that is pretty much it for the test statistic and p-value along with the conclusion. Let me fix this part. It should say fail to reject. Okay, and then keep in mind in terms of what it means, if you fail to reject HO, that means that this is true. If they wanted a more explanation in terms of plain terms, if you fail to reject, it means this is true. So that means that we don't have enough evidence that sigma is less than 0.47 pounds. If you reject HO, then it means that yes, you have sufficient evidence that sigma is less than 0.47. And that's actually it for this particular one.